Oh, hey there. This is 2-2, the fourth video, the last one, I promise, of adding and subtracting rational expressions. I've changed shirts like 3 times. What is this? Madness. Okay, so I'm going to go over 2 more examples, and then there'll be 2 practice problems, and then the closure for this lesson. Okay, so let's jump right in, since this has been a lot of lessons. Here we have this example, okay, -4 over x minus 4 plus 3x over x plus 3, and we're asked to add and subtract the given expressions. State any excluded values. Well, in order to do this, again, we need our LCD. Gotta have the LCD. So this one's simple. I mean, I just take the 2 pieces. X minus 3, x plus 3, right? 2 different pieces, okay? So from this, we know that our excluded values are x minus 4 equals 0, x minus 3 equals 0, and I solve. X cannot be 4, x cannot be -3. Okay, so there's the LCD, there's the excluded values, and so what we have to do, we have to go ahead and introduce these factors. So we have -4 over x minus 4 plus 3x over x plus 3, and I say, okay, what's missing? The x minus 4 is missing the x plus 3. Okay, and the 3x over x plus 3 is missing the x minus 4. Okay, so after we multiply these in, we get -4x minus 12 over x plus 3, x minus 4, plus 3x squared minus 12x over our same denominator, x plus 3, x minus 4. Okay, so I have a common denominator now. Well, now that I have a common denominator, I can go ahead and I can add these together. Okay, so this gives us 3x squared. Got a -12x and a -4x. I'm combining. That's going to give us -16x minus 12 over x plus 3, x minus 4. Where x cannot be, sorry, -3 and 4. Okay, so there it is. There's your answer. Nice and easy, right? All right. Okay, next example. Here we have -14 over a polynomial plus x plus 2 over another polynomial. So in this case, we do have to factor. So -14 over, and this looks like x minus 3, x minus 8. Over here, x plus 2. This looks like x minus 3 times x minus 3. Okay, or x minus 3 squared. So again, what is our LCD? I can just do this off to the side. It is, okay, whatever's the same. Okay, so I have an x minus 3, and then whatever's left over. So I have an x minus 8, and then I have another x minus 3. Okay, so x minus 3 squared. That's going to be our LCD. So we'll go ahead. We'll multiply it in. On this side, I just need the x minus 8. On this side, I need the x minus 3. Okay, that's kind of a shortcut way of doing it. If Ms. Page wants you to write it all the way out, then that's what you're doing. Okay, but I'm okay if you do it that way. So I have -14x minus, that'd be what, 42? Okay, which turns into plus 42 over x minus 3 quantity squared times x minus 8. Plus, over here, we get x squared minus 6x minus 16 over our denominator. Okay, again, where did I get these values? Well, all I did, right, was distribute a negative 14 times x, negative 14 times negative 3, which gave us the positive 42. Over here, I FOILed this out, right? X times negative 8 is negative 8x, positive 2 times x gives us a positive 2, giving us a negative 6x, a negative 6 for our b term, and then positive 2 times negative 8 produces the c value of negative 16. So I have my common denominator. Now what I have to do is I have to add them together. So I have x squared, okay, takes care of u. Negative 6x, negative 14x, this gives us negative 20x. Okay, and then a 42 and a negative 16 give us a positive 26. Okay, all over x minus 3 squared, x minus 8. 8. Okay. Excluded values, Schwarberg. Don't forget your excluded values. I didn't forget them. Okay, maybe I did up here. X cannot equal x minus 3 equals 0. I know I have 2 of these. I know. Okay, so, but what does that mean? Well, I mean, x can't be 3. That's it. I mean, you can do it twice. You can write it twice if you want. Be my guest, be my guest. Put the service to the test. Okay? That's Beauty and the Beast if you don't know that. 3, 8. Done. Okay, that's it. I have practice problems for you. Please pause the video right now. Pause it. Do it. Pause it. Okay? Pause it. Hopefully you pause the video. Hopefully you tried this one. If not, pause it now. Okay, and here is the solution. Okay. Not too bad. Up here you had difference of squares. And then next practice problem. Okay, so again, please pause the video now. Okay, hopefully you paused it and tried it. And here is the solution. Okay, so that is the lesson. That's adding and subtracting rational expressions, all right? So before we sign off, I want to talk about what we're doing here. What we're doing is combining rationals, right? And there's this idea in math of closure, is something closed. And the idea of closure is that if I take two elements and I put them together, are they the same like type of elements, right? Kind of like if I take a player from the Green Bay Packers, oh, he's over here, right here, right? If I take Aaron Rodgers, okay, and then I'll move my head this way, and then I take Brett Favre right here. He's an older player. Maybe you guys don't know him. And I put them together. They were both on the Packers, right? They're both Packers, still Packers, okay? But if I take Aaron Rodgers and I take Tom Brady, I put them together, well, that's like an all-star team, right? That's not the same set. So, okay, that's a different example. I'll do math. If I take a polynomial, I'll keep it simple, a monomial, so x squared, and I add it to an x, right? Is it still a polynomial? Well, yes, right? So that's how we say it's closed under addition, right? If I add them together, if I take an element from this set, an element from this set, the same sets, and I put them together and it's the same type of set, then yes, it is closed. So here's the closure question. It says a set of numbers or expressions is said to be closed or have closure under a given operation if the result of the operation on any two numbers or expressions in the set is also in the set. So here's the idea. A set of rational expressions includes all expressions of the form p of x over q of x. So if I add a fraction with another fraction, do I get a fraction? Yeah. If I take a fraction and I subtract a fraction. Do I get a fraction? Yes. Okay, and then here's our answers here. So yeah, because if I add two rational expressions, it's going to equal a rational expression. Duh. Right? Same idea with subtraction. Okay. I hope you liked the videos. Thanks for watching. If you need to rewatch, please feel free to rewatch. All right. Catch you next time. Peace. Go Pack, go.